good.
share. All right. So thank you, everyone, for sticking pretty close to on time here, and we will get started now with Ann Parsons talking about BECA.
Okay, well, thank you for sticking through to the end. I'll be talking about the bulk elemental composition analyzer called BECA. And this instrument is part of the DOLI program for advancement for future lunar instrumentation. This instrument is being developed in partnership between NASA Goddard Space Flight Center, Johns Hopkins APL, and the Schlumberger Technology Corporation I'll talk about very soon. What I'm trying to talk about or generate the idea of using a pulsed neutron generator with a gamma ray neutron spectrometer to very quickly have an instrument that very quickly can be used to survey a region for interesting elemental compositions. This little cartoon here shows a rover traversing a lot of the area on the moon. And here on my next slide, I want to indicate that BECA can measure the subsurface composition as its rover traverses the lunar surface. And here's a cartoon showing the BECA instrument on a little rover. It is sensitive below the surface, down to about 30 centimeters with the gamma ray, and on the 50 centimeters meter scale with our neutron. Because we bring a pulsed neutron generator with us as our excitation source, we can make our measurements very quickly in 15 minutes to an hour or so, instead of the 8 hours or 10 hours that might be required for a measurement using galactic cosmic rays as the excitation source. So what I'm looking toward is being able to produce traces like shown here, where we've got individual elements, and we show the concentration of these elements as you traverse across the moon. So I'll go to the next slide. BECA consists of a pulse neutron generator, or PNG, gamma ray spectrometer, and neutron detectors. And in this upper right drawing here, I show the individual elements. The pulse neutron generator is a deuterium-tritium PNG. That means it will produce 14 MeV neutrons in all directions, and those that go into the lunar soil, the lunar regolith, will interact with the nuclei of the material and cause it to emit gamma rays. These are characteristic gamma rays that are specific to the nuclear reaction that created them and the element or isotope that created them. So what we have is, when we have the gamma ray spectrometer, we use its spectral information to determine by energy what elements are there, and by the intensity of that peak in the spectrum, we determine what abundance there is of the element. So, as I said, we have elemental composition down to tens of centimeters beneath the instrument. So this is very complementary to a lot of surface measurements, because that deep you're not affected by surface processes. And I want to note that we're making volumetric measurements rather than at a point in the surface. What I mean by that is it's bulk composition. It's the average over a volume about a meter radius and 30 centimeters deep beneath the rover. So it works out very well complementary to other surface measurements like X-ray fluorescence and such. We have a wide variety of elements that are available. Of course, it depends on the amount that's there for detectability limits. This instrument can be used on a static lander as well as a rover or an astronaut deployable package. It allows quick measurements with high sensitivity, as I indicated before, and I won't have time to get into it, but the timing of the pulse neutron generator pulses allows us to reduce the background and make the data analysis easier. And I'm going to have an LPSC poster as well, so I can explain that later for those who are interested. But what's nice about this type of instrument is that it doesn't require any window, any preferred orientation. There's no moving parts, and it doesn't require any sample handling. You're just sitting over the material you want to measure. You don't have to touch it. This instrument is adapted from instruments used in the oil fields on Earth. The way they are used in the oil field is by having a long, skinny instrument that has a neutron generator co-aligned with a gamma ray spectrometer, and they put that instrument down an oil well, pull it up, and while it's being pulled up, it's determining the elemental composition along the depth of the well. So they can determine the rock formations that are below the surface. We're working with Schlumberger Technology Corporation, who's a big player in oil well services. So just a real quick overview of geochemistry measurement techniques that are available. I already talked about BECA. You might compare BECA with the DAN instrument on Mars because it also has a pulse neutron generator. The difference between BECA and DAN is that, well, they're on Mars, but they contain neutron detectors but no gamma ray spectrometer. So they miss the large range of elemental compositions available through the gamma ray signal. Now, compared to LIBS or X-ray spectroscopy, we're a volumetric measurement rather than a superficial measurement. And so in cooperation with these type of surface techniques, we can make a very useful synergy to get complete information. So I'll try to speed up. The point of BECA is that it can really enable some new science in that it can measure the bulk composition beneath the surface and is less sensitive to effects of space weathering. These elemental composition information will provide important geochemical constraints on the thermal and compositional evolution of the moon. And in addition, it can provide in situ ground truth validation for orbital composition maps. And finally, we're using this instrument to determine the element composition below the surface, so it'd be very useful for ISRU applications. So for the DALI program, we're adapting the commercial Schlumberger pulse neutron generator to reduce the mass and the power to make it more flexible in application to the moon. At Goddard Space Flight Center, we're going to adapt the Schlumberger control electronics for the PNG to the space applications. So we're working very closely with the company to be able to make adjustments to the design to handle the radiation environment that we have in space. We're going to use APL's data processing unit that has much heritage in like the Messenger mission, and it's going to be used in Psyche and Megane as well. So these individual components have varying TRL levels. Some of them, like the neutron detectors, are helium-3 tubes. They've been around forever, so they're TRL-9. They're not where we're concentrating our work. It's the neutron generator and control electronics that's new, and we're working with Schlumberger to make that system work. And toward the end of our 3-year DALI program, we're going to have the complete BECA instrument on top of a little rover that APL operates, and we're going to prepare a sample of sort of lunar material. It's going to be a very large area, but we're going to make a thick layer that's 15 centimeters, 20 centimeters deep, and bury plates of titanium, iron, high-density polyethylene, and rode the BECA instrument over those areas to make sure that we can detect these new materials and determine how efficiently and what the spatial resolution is in that detection. Our next steps are fairly clear. This is the first year of the DALI program, so BECA's not ready to be proposed for admission yet. But at the end of the program, we're planning on proposing to the CLIPS program. And also, just as an aside, with very few modifications, BECA can be used for other applications like Venus Surface Lander, or it's also similar to an instrument that's going on the Dragonfly mission to Titan. And that's it. Thank you very much for your attention.
Thank you, Anne. There is a question. What about mercury? Will you be measuring mercury?
So,
element, not the planet.
Oh. We're not that sensitive to mercury. It's a matter of nuclear cross-sections, and we don't have much experience detecting mercury.
All right, thank you. Okay, so that was our last talk for the day, and I want to thank all of the speakers, and we all owe a big thanks to Barb Cohen, who organized this meeting. A couple of quick announcements as we wrap up. There will be a league town hall at LPSC. That will be on Wednesday at noon in waterways 1 through 3. So hopefully we will see you there. And then I think this was a huge success. It was really exciting to hear about all of this really interesting funded projects going on. And I hope you all are as inspired as I am. We will build on this format of the virtual meeting and hold another virtual meeting sometime and probably in late spring, early summer, to follow up on our last in-person meeting in terms of the white papers that people will have nearly finished at that point, I'm sure. And then our League Science Goals document that we'll be working on as well. So thank you all so much, and thank you to Ricky Guest at Goddard for running the Zoom.
I'm at Ames.
Oh, you're at Ames. Okay. I'm sorry. I've just assumed since you've been working with Goddard. Thank you. And that is all for today. Thank you so much, everyone. All right, see you at LPSC.